Hello again, Internet. Alright, well, that took a little bit longer than expected. Who would have thought that light technology was complicated? Uh, so, after a lot of research, it looks like LED is the best route in spite of the fact that it can't really handle the high temperatures of some of the other lights or light source methods, but I still think it's going to be the best option. So, what I came up with here is we have this light, and you saw that before, and just going with a really big heatsink, since no matter what I looked for, I couldn't seem to find a small heatsink that also had good enough thermal dissipation. So I figure a big heatsink, and you can have two pieces of quartz glass with a gap in between them. According to the math I did, if this machine, the 3D printer is running at 150C inside, and it is 25C, and I want it's 25C in here, then, well, that would be like an extreme worst case, highly unlikely scenario. But um, in that case, 90 watts of heat could go through one of these panels. By having two of them, I basically cut it down to 45. So just, I think 45 watts should be acceptable, especially with the heatsink right here. But at the same time, if I put one more in, it's diminishing returns at this point, but it might be worth it. Also, I wanted to mount these little quartz glass sheets and couldn't really find a great way to do that with anything off the shelf, but I did find high temperature silicone rubber foam, and it just comes in these big sheets. And apparently the stuff is laser cuttable, so I can just design gaskets and spacers and whatever I want out of it, which is fun. Uh, so with that said, might as well get started on this design. So, oh yeah, along the way I found a few other things, pre-made gasket material, not that great. And let's see, I found something like this. Just took up way too much space. And let's see, I also had just some edge sealing, but again, just takes up way too much space. Hope I broke external references. Hope it's not too late to do that, but we'll see. So I just kind of designed like a very basic box that would go into, and yeah, then it just screws into the heatsink. The box will extend down to the heatsink, so the box also screws into the heatsink. And I'm not sure if that's going to be sheet metal or it almost has to be sheet metal. Um, and then the heatsink itself will just kind of screw onto the top of the machine. So there'll be three of these, and the machine's kind of triangular to begin with, so that should look nice, I think, maybe. But yeah, let's get started on doing some actual design here. So I already figured out that I want this plate, uh, and it should not be directly touching the lens, obviously. I forget exactly what numbers I used to figure out how far away it is, but I'm good with it. So I'm gonna look at this. So this material is just under 1.6 millimeters thick. 1.5875. Uh, Actually, you know what? I'm just going to call it 1.5 and just assume that it's compressed a little bit because it compresses quite a bit. So if I do that, Alright, so that's our distance between the two glass plates. Now I can put in a new part. That will be a gasket that goes in there. And edit that. Create a new sketch here. And I want to offset this by 3 inward. And then I want to also offset this by, I think 2 outward should be good enough. And I'm going to extrude it up to there. Nope, that's not where I want. Up to surface. There we go. Okay, so now if I hide that, yeah, we've got a little gasket in the middle there. Then I'm going to make another one, another new part, and create a sketch there. I'm going to convert that, and I'm going to convert that, and I'm going to extrude it up by 1.5. Alright, so that's one potential issue there. We've got, the stuff's 1.5 and it's about the thinnest I could find. I guess it could be compressed down to 1.5 pretty easily, or down to 1 even. Alright. So, yeah, I'm going to call this compressed down to 1. And we can take that and copy it down. Alright, then we can take this one and copy it to the top and bottom. Alright, grab it. And mate that. And we gotta grab this one out of here. There we go. Alright, so we just got basically a stack of pieces cut out with a laser cutter there. It should work well. Then we can surround those in something. So it could be milled, 3D printed, or potentially sheet metal, although normally sheet metal is the cheapest, but when you're at low volumes, it tends to be the most inaccessible and most expensive. One thing I should check though is if this is actually able to get into the machine. So that's 13 millimeters, and I need, well, I can probably get away with making it cut out in the top for this. Well, maybe. Let's go measure this. What's that? Oh, all right. So I'd like to mount the heat sinks up here, and I can't really mount make cutouts to mount them lower because then they'll be in there, and I want that to be pretty much full of insulation. So got to measure from that to the inside. Let's see. hide that, and it's gonna hide the whole filament cover group. All right, so it has to go all the way through to down to here. And how far is that? That's 47.625. Let's see, 47.625. Oh, what did I do? There you go. And go back here. Just gonna hide this. So I need to make a new plane. Ooh. Okay. So let's see. I'm gonna close this. Just every now and then I like to tidy things up and also just save everything so I don't lose everything. So I need to think of a way to bring this out. Not sure how. Not sure how. Yeah. The problem is that if I just bring this out and it's just straight out and the light is still at the back, I lose a lot to because this is not like there's not a straight out reflection. I lose a lot. So I'd like to keep the lenses and everything close. Maybe I can do something that's like angled up, kind of a triangle there. It's an option if it ever finishes saving. I need to go and look at the data sheet again. See, I don't need that anymore, or that, or that, or that, or that. I don't think. I apparently do still need that. I don't know what that is, but okay. Alright, that is done. And I shouldn't have closed that. Alright, what kind of angle does this thing project at? Alright, not much help there. Is 125 degree. So let's go to this part, add that in. That's good. And I realize there are easier ways to do this probably, but I just like doing things with geometry. Call me weird. And Circular. Okay. Why did it do that? Equal. Equal. That's okay. Am I in a 3D sketch? No. Alright. Alright, SolidWorks does things weird sometimes, so I guess I will do it mathematically. Alright. And how long should that be? Maybe 100 should be enough. Alright, and I don't need this one, and this one needs to be for construction, and I want to do a revolve surface, just like that. Okay, make that pink. Alright, so that's pretty much how the light is, or the LED is shining. So let's go back here again now. So as it was getting clipped just a little bit, but not much. But as you can see, if I went straight up like that, I'd clip a lot of it out. Yeah, so minimal clipping so far, but yeah, if I can get that a little bit closer, that might be preferable. It should be good. I just need to build this up to there, which can be done. And edit this. So to start, I am thinking of just doing this in Ultem because, well, machining it's going to be kind of expensive. Sheet metal, would sheet metal work? It has to be bent, and it's not going to be sealed very well. So, yeah, so great use for this very printer is to make stuff like this. Alright, and yeah, I probably just want to go right over to there. Or I want to go to there. Let me get that. There. Alright. And then if I offset all of these by, I don't know, 6. 6 works. Just barely. It does cut off a lot more light, but that's okay. We can adjust for that. And connect there. Let's see if we can get that line, convert that. So if we make this parallel, so it shouldn't cut off any more light than was already being cut off. If we do it like that. Alright. But yeah, it's not as strong as I'd like. So if just make a little bit of a straight area just to give it a little bit of strength. One should be enough. Oh no, I want to go parallel with that. And put that to construction, just draw in this little section. Okay, so we got a closed contour. And can it be, Well, we'll try. So up to surface, there, up to surface. Come on, give me the surface. There we go. All right. And then we can make a couple of reference planes. And I'm going to hide this body. And please don't quote me on that. Okay, and bring it back. So now I want to make an axis using those two planes I just made. And then I can do a circular pattern of bodies. And alright, so what happens if I look at this on its own? Alright, not too bad, I think. So probably should have made this a little bit larger when I was starting. And direction 2 is 20. Okay, a little bit more like it. I know it's a mess, but I can clean that up easy enough. Just going to copy these two surfaces and copy these two. And select all four of those. Do a split with all bodies. Cut bodies, all bodies, yes. So then we have those that we want to keep. And all the rest of that is trash. So and combine these. All right. So now, of course, we just made something that's impossible to assemble. That's a bit of an issue, but yeah, not a huge one. But it's before I worry about taking it apart, I just want to make sure everything around it is set up. So like, yeah, it doesn't come all the way down. So that we want it to come all the way down. So I make a plane that's coincident there. I can open it up over here and just continue it down. And just bring it down to, I thought I just made a plane. I guess I didn't. Part features plane coincident, yes. Okay, do I have a plane now? I do. Good. Alright, so if I hide this, because I've pretty much got a good idea of what that's doing, and I'm going to put this to transparent, and I'm going to put this to transparent, because those are pieces of glass. So then we can see into there, light source, and next problem is that it looks like we have all these screws going into, yeah, But that's easy enough to deal with. Go back to McMaster, and we want a washer, and just want a washer, just want a flat washer, but I want it to be made out of plastic, and want it to be high temperature resistant, which I don't know if I'm going to find that in a plastic washer. What else can I have? Titanium, nickel, bronze, brass, copper, aluminum, steel, stainless. Okay, so yeah. Oh, or ceramic. Actually, there we go. That sounds about perfect. Oh my, that's not ideal. So let's filter it down to the size range that I could actually use here. So that's pretty much it. What's the SAE equivalent? 0.118. Just a few in that range, it looks like. Oh, I don't know why it went back down. So it looks like with 1/8 inch being right there, that works well. For some reason, there's no search for temperature here. Let's try just the ones for M3. So maximum temperatures are not impressive. 50 chemical resistant plastic washers, 500 Fahrenheit. Yeah, that's more than I need. Okay, so there's, what else we got? 500 degrees, 10. Okay, we have one winner. All right, get the number. And so this is just an oddball thing. I'm just gonna download it as is and actually download the SolidWorks version of it. Don't know why I bothered to do that. They didn't bother putting material on there. Alright, and let us save this. I'm not even going to put this in my library. I'm just going to put this in the 3D printer. This is kind of an oddball thing. Alright, and before I do that, we advise conductive anti-static PC due to the. So do they. Some of it is, and some of it isn't. Okay, so if it has stuff added to it, then it is. And this, who knows? I mean, I guess guess I'll go with it for now. Let's if it fits even. Yeah, before I work too hard on that, let's see if it even fits where I need it. Let's hide that and that and that. Alright. Where is this hidden? Okay, let's hide this as well. Okay. So, how's this made it down again? Got coincidences. Alright, let's just mate this in and see how it fits. Okay. So that should fit, I believe. Alright, so it hangs out the side a little bit, but should be okay. I can just do a little cutout for that. That's not a big deal. Or I could even just cut a little bit off of one of those. Not a problem at all there. It's just PTFE. You can cut that with like an X-Acto knife. Alright. So that's a winner. Then we can screw it right down into there. We still need some kind of wiring harness setup, but that can actually go forward into the compartment that it's going to be in. So let me bring everything back again. Okay, go back into this, or actually, nope, we do not want this one. We want this one, yeah. And we need to show this again. So it needs to get all the way up to there. Let's see what can be done about that. Collinear and coincident, and we have a pretty long thing sticking out there. Alright, I'm going to do the same thing on the other side just to get an idea of what kind of dimensions we're looking at. And make those equal. And just take that measurement there. 153 millimeters. Alright. It's a little bit bigger than I'd like, but yeah. What if this was a round aperture? And it's still going to be about the same size, but it's not going to be as intense, I think. Let me try that. Yeah, so like right here, it's about perfect. It really is. I mean, the little bit that it's getting, those are the tiny part of it. So if I go back to the LED, and I'm going to hide that again. So I want to basically use this and do a revolve that generates, well, shoot, no, I can't do that either, because then I lose contact on that. But if I do a revolve that starts above, that just looks silly. I guess I could just start it right here, actually. Get out of the way. And right, I'm gonna hide this for beginners. I'm gonna break all because I'm gonna do some stuff that's probably gonna break everything because I'm changing concept. And then this. I could put some fillets on there. Actually, I can just put a circle in there. Tangent, tangent, and tangent, and we have a circle, and then just do the outside. There we go. Do I want that? No. Alright, I'm just going to leave that part cut out. That's fine if that's part is square, but we want the next part to be round. And hide that. So I want, starting with this component, I want it to be round. And hide these planes because they're otherwise going to get in my way. And sketch there. So same deal, except this time I can just use this axis and do one tangent. And I'll just convert and extrude up by just 2. Oh, 2. Oh. Nope, 3. Okay. Yeah, that looks like it should hold okay. I'm gonna put a chamfer on there. That is 3, and it's 45 degrees. And I think that looks okay. So then I want to extend this all the way up to that surface that I need. So I'm going to put that surface into this part. And just do a coincident. And now I've also got that surface in this part. Alright, so there is my, is that? I just use that one just in case. And I'm going to do an intersection curve, which that gets me those lines. I don't need this one. And collinear, and I want a coincident up here. Actually, I want it to go, call it 1 millimeter past. Just a little bit. And just a little bit more. Alright, so now I should be able to do a revolve around the axis if I hide this though. And just going to revolve this surface around the axis. Okay, and then I'm going to thicken this going outward by 6 millimeters. And then I have to, I hate it when it does that actually. Alright, I'm just gonna make this longer. And then I can make a plane that's offset by 2 to do the same thing. Oh, And then I want to split using this. And alright, that is weird. I will do a cut then. Okay, so that pretty much works. Let's get rid of this plane, get rid of this plane, because we're now going all the way through. Actually, we want the first plane again, so that I drop here, I'm going to convert inside and outside, and I want to go 3 millimeters past the plane. Okay. From there, we might be able to come in or whatever, but need at least 3 millimeters past there, so that works. And I'm going to convert the entities there. And actually, I'm not going to do that. I'm going to convert these. And one more. Up to surface and this surface. Okay, so I just trapped some air bubbles in there, but probably going to trap some more in there before I'm done. And then I can clean them out later. No big deal. Ooh, and that was not intentional. So let's make a rectangle in there to fix that. Let me grab it. Linear, collinear, and collinear, and collinear. And I can do an extruded cut up to there. Okay. So that fixed that little oops. Or did it? Okay. It looks alright. Let's see how it looks with the lens projection thing. Come on, let me click something else. Alright, so that could be better. Let me actually measure this. Come on, give me the line. Oh. Give me the sketch, then I can have the line. Alright. And let's see. What are you doing? Alright. Oh, give me 2 lines. Just give me a dimension. Alright. 27.5. Alright, let's go back to this. And that. I want to flip the direction. Nope, I want to stay there, but I want 90 minus 27.5. Hmm. 5. That works. Maybe. Alright, so that was already coming up. I don't need that extrude anymore. And the cut's done. That looks good. How big is this now, though? 184. That's tolerable. Yeah, that's tolerable. So So I think we got a winner there. Now this whole bracket needs to screw into this as well. And how am I going to do that? Well, if I edit this part, and I am going to select some surfaces of this other part, and then I'm gonna offset them to 0, and then I can go back here and it's a little bit easier to work with. So I want to, might as well just start a sketch right there, and if I hide this, I could do a convert just so it's not eating up or not covering up things that I already designed that I want to keep. And up to there. And oh, actually, I do not want it to use the entire surface, come to think of it. So what if I, let's see, reverse. So I want 5 plus 5 plus 3. That allows me to have an M3 screw. The heck? 13. Okay. So now I can have holes in the panel to actually have room for screws there. Although I should check that in the assembly first. Yeah, sure. So I'm going to insert a screw just to see what I'm looking at. Hardware. Oh, I want there. I do not want button, I want socket and hex, M3. Good, good. Wait, do I want that? Then I need an insert. Yeah, I can deal with that. Well, especially this will be just, sorry, this will be screwed to the top of the machine. Then I don't need an insert for that. Alright, do I have room for a screw in there? I think just barely. Beautiful. Alright, so I'm going to edit the heatsink real quick. Because I want to convert and convert. Then I can put the midlines in. It's going to go like that, and like that, and that, and that. I can make these all parallel and equal. And then I make this like that, parallel. Alright. Go from there to there. We want the radius of the screw plus at least 6 millimeters. Okay. That's all for construction so far. And circle, 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 circle. No, equals. Then 3. Yep, that works. Alright, so now I have those holes. I break all external references at this point. And so I've got the screw. I need 3 more. And just going to mate all these so that they don't fly off too far, hopefully. Why am I unable to? Oh, alright. Hide, maybe? Just will it stay hidden? Okay. And more, so I know what I'm dealing with. And yeah, it looks like those are set. Then I just need to make sure they're not rotating and saying that I'm not defined, even though it's just a screw and it can rotate, not a big deal. That way we're fully defined. Oh, or apparently we're not. Oh, that washer's in there. Yeah, that washer's in there. Suppose I should deal with that. Hide you. 1, 2, 3, 4, 5. Hide. Alright. Coincidence. Is that it? Okay. So I need 3 more of those as well. And there. Okay, they don't seem to be interfering with each other, at least. And there we go. There we go. Alright, so that's sorted out. And this is going to have tapped holes for those, which is why my screws are designed with the shafts at tap hole diameter. Well, it's one of the reasons, is that I can just do a cavity and then I've got tapped holes. Alright, so what's not defined now? Oh, washers still, because they rotate. And now it is fully defined once again. And I'm going to hide this one, and I want to just get rid of this one. Not needed anymore. And show everything. What is not defined now? Oh, that. So I want to just copy the name of this part. And then I'm going to hide this. I'm going to open this part. Actually, I can just edit it here. And there we go. And then this one. Works. So then I want to save these 2 parts externally. Where are they going? That works. And show with dependence, Control Q. What am I? There we go. Delete that. Control Q again. And we're fully defined. Hooray! It's not done yet, but it's fully defined. Alright, so now get back to this. And can make a sketch on that. And let's see if I hide this. And I'm just going to convert that as it is. Then I want to show that, oh, actually I don't need to show that again. I can use this right here. And I'm going to extrude up to surface. There we go. All right. I think that should work. Then we just need a way to split it, which I feel like should be relatively easy at this point. Because we've got big chunky areas to have screws and inserts and whatever else we might want. Alright, so hardware. Oh, I need to go back to the assembly to do this. Close U. Insert. And go back to my hardware folder. See what we got that will work, and if one of these will do the job. So if I put a screw in this way, not ideal. I've got another one in here somewhere that might work better. Just hide some stuff out of the way. I've been talking too long. I think my voice is starting to go. Alright, so they look very similar, but this one's designed to take a screw in that the head of the screw is on this side, whereas this one's designed for the head of the screw to be on this side. So if I can place this one up behind this surface somewhere and run a screw into the back of it, and that'll work much better. But tell you what, my throat is starting to get a little bit dry from talking all day. So I'm gonna call this end of stream, I guess. And well, I'm gonna call it the end of me talking during the stream, at least. Maybe on later, but it'll probably just be a silent stream unless there's some people asking questions or something. So yeah, I'll be back in a little while. Just need to rest my voice and drink something.